everyone, it's Mrs. Bebo. In this video, we're going to take a look at subtracting rational numbers, which leads us to our main learning target for today, which is how do I subtract rational numbers? Now, the nice thing about subtracting rational numbers is that it is the same as when we subtracted integers. So remember, to subtract integers, we keep, change, change. We keep the first number the same, we change the subtraction to addition, we change the sign of the second number, and then we follow those rules for adding integers. So the other thing we have to keep in mind, besides our rule for subtracting integers, is that we have to remember that when we add and subtract fractions, right, we need a common denominator. So that's the biggest thing to remember when we add or subtract fractions. Common denominator is needed. And then when we add and subtract decimals, again, the biggest thing with this is that we just need to make sure that we line up our decimal point. So for our first set of examples, on the left side we see it says find -3 and 27/100 minus a -6 and 7/10. So the first thing we should do is keep, change, change. So we're going to keep the first number the same, so -3 and 27/100. We're going to change that subtraction to addition, and then that -6 and 7/10, we change it to its opposite, so +6 and 7/10. So now my problem looks like the following. Right? -3 and 27/100 plus 6 and 7/10. We have different signs. We have a negative, and then we also have a positive. So because they're different signs, the trick here is that we're going to end up subtracting these two. So if I write my work off to the side, we're going to be doing 6, and we can write it as 70/100, so that way we can make sure that the decimal points lined up with that 3 and 27/100. So subtracting these two, we'll have to do some borrowing here. We end up with 3 and 43/100. That is going to be my final answer for this question. Now, we do need to make sure, though, is the sign okay? Is it actually a positive? And yes, it is, because we had more positives to begin with. So my final answer for this one on the left is 3 and 43/100. Now for the question on the right-hand side, it says we're going to find 3 and 58/100, subtracting the -2 and 9/10 from that. Again, we're going to keep, change, change. So this problem is going to turn into 3 and 58/100 plus +2 and 9/10. And now what's really nice is that these are the same sign. They're both positives, right? This is a positive, and this one's also a positive. So we're just going to add like normal. Again, I can show my work off to the side here. 3 and 58/100 plus the 2 and 90/100, because again, we want to line up our decimal point. And then we just add these two values together, making sure we carry down our decimal point, and we get 6 and 48/100 as our final answer for this next question. So now taking a look at these ones here, we have some fractions now. And again, the biggest thing with fractions is that we do need a common denominator. But step by step, my first piece of advice for students is to rewrite the problem as addition, right? So keep, change, change, and then worry about the common denominator piece. So with that being said, this first one we're going to rewrite as 5 and 1/3 plus +4 and 5/9. And again, what's really nice is now we just have two positives we're adding together. So it's just normal addition with fractions. We do need a common denominator. So now that we've rewritten it, we are going to use a common denominator of 9. Again, there's other options, but 9 is the least common denominator, and so it's going to make the problem a little bit quicker to solve. So we're going to have 5 and 3/9 plus 4 and 5/9. Adding the whole number portions of our mixed numbers, the 4 plus 5 is going to make 9. The 3 plus 5 is going to make 8, and then 9ths. So 9 and 8/9 is my final answer for the problem on the left. And now for the one on the right-hand side, it says we're going to find -1/2 minus 2 and 2/5. Again, writing our answer in simplest form. When we do this one, again, before we worry about a common denominator, just worry about keep, change, change. So keep the -1/2, change the subtraction to addition, and then that 2 and 2/5 is going to become -2 and 2/5. Again, a really nice question because we actually have the same sign, so we're going to add like normal and keep the sign. So my answer is going to be a negative in this case, but we need a common denominator, so a good one in this case would be 10. And so writing out my work so we can see what we're multiplying each fraction by, that first one's going to turn into -5/10 plus, then we'll have -2, and then this will be 4/10. And again, they are the same sign, so we're just going to add like normal. The -2 is actually still going to be there, and then we have the 5/10 and the 4/10, which is going to make 9/10. So this final answer is going to be -2 and 9/10. Now, just a side note on this second question that we just went through, that one on the left, or sorry, the right here, you actually could solve this question using decimals. So you could change that to -0.5, right? -5/10, -2 and 4/10, right? 0.4. And then you would end up with the same answer. It would just be -2 and 9/10, right? So just as an option, even though it does say write in simplest form, I know that for my students, I always tell them you can write it in either form as long as that decimal is one that terminates. All right, so moving on to our next example. So now we're going to evaluate some algebraic expressions that, again, require us to subtract, which then we'll rewrite into an addition problem. So the only thing with this is that we have an extra step of making sure that we're plugging in those variables or those values for those variables correctly. So for this first one, it says evaluate x minus y if x is equal to -2 and 4/5 and y is equal to 1 and 4/10. So plugging in our values, we're going to have -2 and 4/5 minus, and then we have that 1 and 4/10. Now, this is another question where you guys have the choice to keep this as fractions, or you could rewrite these both as decimals, right? So these are both valid options. I just want to stress that. You could do either one. I'm going to go ahead and change that -2 and 4/5 into a decimal. So this will be -2 and 8/10. And then we're going to keep that. We're going to change the subtraction to addition and change that -1 and 4/10 to its, we're going to change what is now a +1 and 4/10 to its opposite, which is -1 and 4/10. And now what's really nice is that these are the same sign. So we're just going to add like normal. Again, if I show my work off the side, 2 and 8/10 plus 1 and 4/10. This is going to end up being 4 and 2/10. However, our answer is going to be a negative since we had two negatives that we were adding together. Now, if you were to solve this using fractions, you would just have -2 and 4/5, right? So this is the other option. -2 and 4/5 plus, this will now be -1, and then 4/10 as a fraction is 2/5. And so we can add this to get -3 and then 6/5, which is the same as -4 and 1/5, which is equivalent to -4 and 2/10. So just as another option there. And that's going to be true for the second question on this slide too. Evaluate a minus b if a is equal to -1 and 6/10 and b is equal to 7/10. So we have the option again to either keep these both as, or change them both into fractions or change them both into decimals. You do want them in the same form though. So if I write out the problem originally, it's going to be -1 and 6/10 minus, and then we have the 7/10. So I'll do this one again using decimals first. So we have -1 and 6/10. And again, I'm going to keep that. I'm going to change the subtraction to addition, and then that -7/10 is going to look like that. So -0.7. All right, and now we're just going to add like normal. So the 1.6 plus 0.7 essentially is the math that we're going to be doing. Again, if you want to show that off to the side here, just in case you need to see that worked out, it's going to end up being 2.3. But again, it's going to be a negative because we had the same sign, so you just add like normal and keep the sign. Now, if we were going to use fractions on this one, you are going to have -1 and 6/10 plus, again, this -7/10. So -1, and then the 6/10 plus 7/10 is going to be 13/10. And then this is going to end up being -2 and 3/10 once we rewrite that into its proper form, which again is the same exact thing as what we have from when we did it using decimals. All right, so last example, same idea, just to really make sure we get the point across of how we evaluate expressions and how do we subtract with rational numbers. So x minus y if x is equal to 3 and 3/4 and y is equal to -4 and 2/10. So again, we're evaluating this for those specific variable values. So we can write this as 3 and 3/4 minus, again, -4 and 2/10. So with this question, we're going to keep change. I'm actually going to go ahead and change, though, the first number into its decimal form. So this will be 3 75/100ths. And so we're going to keep that number, change it to addition, and change that -4 2/10 into its positive value. And if we want to, we can add that 0 on the end. And then when we add these together, we're going to get 7 95/100ths. And that's it for that question. If I were to do this using fractions, though, just to take a look at that, we would have, again, this problem rewritten as addition. So it'd be 3 3/4 plus that 4 2/10. So that's going to be 4, and then we can write that as 1/5, right? Because 1/5 is the same as 0.2 or 2/10. And then we need a common denominator. So a good common denominator in this case is going to be 20. So we would multiply each of these by 5, multiply each of these ones by 4. This is going to turn into 3 15/20 plus 4 4/20. And then adding that together, we get 7 and then 19/20, which is the same thing as what we got before, but again, in fraction form. So hopefully that helps you with subtracting rational numbers. Thanks for watching.